Is core concepts, understand the Kubernetes API primitives. So now that we have our cluster up and running, we could actually understand some of the core features it has through the APIs it exposes. This is partially because Kubernetes is all about its APIs. So first of all, Kubernetes actually doesn't just have one set of APIs. It actually has any number of versioned API groups. And different Kubernetes servers may have different versions of these API groups. So the one command you can run to see what API groups are running on your server is the command kube control API versions. And you'll get a list. Left of the slash is the API, so apps, right? And then the right of the slash is the version, so v1. So these are all the API, various, API groups that you have on your server. Now, that's the first piece. The next piece of this puzzle is each of these API groups may expose some persistent objects, things that you create as part of the Kubernetes cluster. And the way you can see what kinds of objects that you can create, persistent objects, and how they're tied back to these groups, there's a command called kube control API resources. And if you run that, give it a second. Okay, what you get is a list of kinds of objects, binding, component status, config mac endpoints, and then it tells you which API group it's part of, right? So which API groups this object is tied back to. The ones that are blank, there's a default, or sometimes called the legacy, or I think the core, I think it is, API group. That's what the blank ones are. So these are kind of your most common objects, your pods, blah, blah, blah. So again, essentially the kinds of objects your cluster has is dependent on the API groups that are installed in it. And I'm guessing pretty much all clusters probably have the core group. Okay. Okay, so let me close the screen here. Okay, the next concept is, if you think about these objects, they all have names, and that name generally is unique for that kind of resource type. So if you have a pod, then that name must be unique among all pods. But there's sort of a caveat to that. It actually, there's a concept of a namespace, which is a scope for names. And for those kinds of objects that have support for namespaces, then the names can be unique, only be unique among that namespace. So I'm going to look at that last command again one more time, the kube control API resources, and you will observe there's another column we kind of breezed over. See this named space? So for example, pods, which are here, they are namespaced. So the idea then is if you want to create pods that have the same names, but you would have to create different namespaces, and then you can use the names in those namespaces that are the same. But within a single namespace, you must have this single name. Whereas things like a persistent volume, see, it's not namespaced, right? It says false. So persistent volume names have to be unique across the whole cluster. Okay, so that's the idea of namespaces, and then how you can tell which objects are namespaced or not. So, okay, next thing we look at is what are these namespaces. So namespaces is an object. It's somewhere in this list. Either way, namespaces, right? Namespaces themselves obviously are not namespaced. That would be kind of crazy. So I'm going to run kube control get namespaces, and that's going to give me the list of all available namespaces and their names. And you can see that there's 4 that come kind of shipped with the system: default, kube node release, kube public, and kube system. So I'm just kind of walk through what these are. The default one is if you create objects and do not specify a namespace and it's a namespaced kind of object, then it will land in default. If you, so that most of the things you will create probably land in default. On the hand, see the cube node lease, it's a system namespace pretty much used for node leases. And cube system is definitely anything that's related to the Kubernetes system, any objects that exist, they will live in cube system. And cube public, it's not entirely clear to me, but basically the gist here is this is where objects get created that are generally available even to unauthenticated users. So I don't have a great use case in my mind, and I've not seen anything yet, but it's there for public objects. So that's the next thing, those namespaces. You can actually create your own namespaces. We're not going to do it here. So let's say, but you're only really going to do that when you have a situation where you have multiple groups or multiple teams of people, and you want to create distinct parts of the Kubernetes system that different groups can use. And you can control access based on namespaces. So it's more for like a larger deployment, multiple teams, right? We're not going to do that in this exercise, at least maybe later we will. But for now, we're just going to live with the default namespace for all of our created objects. Okay. Now, if I do kube control get all right now, you will see that I don't have many objects. This one object is something that Kubernetes will create for me automatically. So there's not much going on here. Now, what you can do is you can do kube control get all namespaces, and you will get a longer list of things. And you notice, for example, you can see in the kube system, which is a Kubernetes system namespace, you'll see I've got a number of pods running. I've got some services here. I think these are services, right? Daemon sets, deployments, and replica sets, right? So we have all these different kinds of Kubernetes objects running. And they're mostly in the kube system namespace. Okay. Oh, and I guess one I didn't mention here is this kube. I don't know if we've used this before, but this get all. It doesn't actually get all of the Kubernetes objects. There's there's secrets. There's all sorts of stuff. Kube all basically gets all the common pod related objects. So like pods, which are basically the things that have to do with your containers. So it's kind of like a friendly way of getting all the common objects that you might be interested in day to day. Okay, so that's what the all means. And as far as I can tell, I still could not figure out exactly what all covers, but it's not well documented. Okay. Let me pause for a second, get myself reoriented here. So hang on a second. Look back at this list again. So of the resources that are currently in place, right, some of them are basically just built into the system, pretty much are always there, and this kube proxy is one of the ones. So these kube proxy entries here, okay, those are ones that pretty much every cluster is going to have. Now, there are two other things here, this AWS node, and see this core DNS floating around? Both of those are examples of add-ons. So they're, you run your Kubernetes system and you want to add some functionality to it. You can deploy these objects into it, using some instructions, and you get additional services, features. One of which is DNS, so allows for, instead of having to mention IP addresses everywhere, I can actually use names, and that's what this core DNS add-on provides. Another one is this AWS node. That is actually called the Amazon VPC Container Network Interface. And what this allows, out of the box, Kubernetes has no concept of pod to pod or container. Let's think of containers for a moment. Ways for containers to communicate across the cluster. Technically it's pods, but we'll get to that later. So there's not a good mechanism for inter-cluster communication that between your, the services that or the containers you're running, let's say. Now the problem here is that, again, out of the box doesn't have it. There are a bunch of different solutions, things like Calico, Flannel, all these. There's a laundry list of about 100 of them. I mean, there's a lot of them. But out of the box, when you use Amazon EKS, they pre-install an add-on called this AWS Node one, which is AWS's way of doing this pod communication. Okay, so again, every cluster needs a solution. This cluster happens to have the AWS supplied way of doing interpod communication. So again, this was just to illustrate that you may have lots of different services here that are part of add-ons, and in this case there was two: Core DNS for DNS, which is common, and AWS Node is specific to AWS. Okay. Okay, so the way we're going to wrap this up now is we're going to go through an exercise of let me pause it for a second. Hang on. What I'm going to do this last step is we're going to install another add-on, right? And we'll just go through the exercise of what it takes to add an add-on and maybe just mess with it a little bit. So the add-on we're going to look at is called, well, let's do first. There's a command here. I'm going to try to run it. Top nodes. And we're going to get an error. But so kube control top nodes basically should if the right add-on is added, will basically inquire to the nodes, find out which of the nodes have the top utilization rate, like what's the most CPU, most memory, this kind of stuff. And you notice it's saying it's got something, it's missing some stuff. And the thing it's missing is called metrics server. So let me show you what that looks. If you just Google metrics server, you end up on metrics server. It's basically a mechanism for collecting metrics across your cluster of either nodes or pods. It's basically a way of collecting data. And they have instructions here, somewhere down here, and we'll actually do the same command. It says you run this command, and basically that's how you install the various resources or objects into your cluster to make this work. And we'll go into the supply command later, but it's a script that basically creates a bunch of Kubernetes objects. Now you'll notice also, if you look at this, Amazon also has instructions on installing the Kubernetes metric server, so should make you feel good that it should work with Amazon. And you will look, if you observe it carefully, it's the exact same command that you saw on the original instructions. Now, when you go to do this and you try to run that top command, you get errors, which is unfortunate. And I end up finding you end up with this metrics not available if you try to run that same top on nodes, and you can wait forever and it never seems to fix itself. And so it looks like there's an open issue right now. Well, they closed it, but it looks like they're going to reopen it again. This actually just closed, yeah. So there's still an issue out here, and I ran into it again. And there's steps here that someone wrote, specifically AWS, this guy here provided a solution, and we're going to use that solution for now. So again, the whole exercise is to learn how to install a popular add-on called metric server. We're going to fix it, and then we're going to use it. Okay, so to install it, we'll just use the Amazon instructions. And I go here, and I paste it, basically grabbing some configuration file that's on the website, and then taking that script and running it through, and it's going to create a bunch of Kubernetes objects for me. So if this works right, you see it's creating these objects here. So it created some stuff, and if I run kube control get all namespaces, you will see now I've got more things running that I did earlier, pretty much This metric server's here. I see metric server here, right? So I got some more stuff running. Everything looks fine. I'm not sure if I mentioned this earlier, but many of the add-ons you might add will come onto the namespace of Kube system, right? Because they're kind of system-wide, kind of, they're augmenting the system. So that's where they typically will show. Okay. If I try to run that top nodes, let's see if I can get it right now. Kube, top nodes will probably replicate the error. See, this metric's not available yet, and you can wait an hour and you still don't see any metrics. So that's the bug, and I searched that, and that's where I found the issue. Now, the fix here is, let's see. Yeah, so there's a thing. Now, again, this is kind of, I don't want to talk about deployments and all this stuff. I'm just going to apply the fix, and we'll see it working, and we'll come back to some of the things that, the way to fix this. So let me, right. So we're going to run a command here called kube control edit. So we're fixing one of the pieces, one of the objects it created was called a deployment object. Again, what exactly it is not relevant at this moment. But we're going to fix that object that it created. It's in the Kube system. So it's in the Kube system. The way this reads is there's an object called the deployment. It's called metric service. You can actually see it right here. It's this deployment metric service somewhere that was in here. Deployment metric server. Oh, metric server. And it's in the namespace Kube system. And when you do that, you're going to get, it's probably metrics server. Right, you get this horrible file that you have to edit, right? So again, I don't want to be too, we're not going to go through all this, and this is more than I'm used to seeing, right? This is basically a dump of this whole object, and you're editing it raw. In here, there's a couple arguments that we're going to add based on that fix that this guy suggested. And the fix is to add these two parameters. These are basically, when you're running that metric server, there are, and I'm going to have to eventually research this more myself, but it needs a couple extra arguments that don't come pre-installed. So I'm going to come in here. Oop. Man. Okay, so I just added two additional parameters to the way that metric server that deployment metric server runs, and this will solve the problem basically. So this will take a minute to settle down. So I'm gonna pause this for 1 minute, and then I'm gonna come back and look at it. So I'm gonna pause the video for 1 minute. So now that I've fixed that deployment, first of all, get all. It doesn't actually change anything parent here. So you run this. You still have your same set of things here, but it actually deployed a new version. This redeployed your metric server with some different arguments that allow it to work with AWS. So now if I do kube control get top nodes, top nodes. Now it is able to communicate with the metric server, and the metric server actually has data, and you can see that I have two nodes, right? I can see how much memory they're being used, how much memory, how much CPU they're using, how much memory they're using. I can find out some core data, some core metrics about our nodes. And we'll talk about pods later, and you can do the same thing with pods. I'll just try it here. See, top pods. Probably won't show anything. Let's see if this works. All namespaces. Right. So you actually can see there's pods, which are basically where your workload's running, and you can kind of see that in the names, in all names in the Kube system namespace, there are services running in pods, and you can see their CPU and their memory. Okay, I think that's it for this video. So thank you.